This video is to show you how to graph the solutions to an inequality that has two variables in it. The three examples I'm going to go over are all linear functions. So to start with, if you look at the first inequality here, and by the way, my scale for both x and y are going to be 1. So I'm going to go ahead and graph my y-intercept first, which is at -4. And then my slope is 3, so I'm going to go up 3, 1, 2, 3, and over 1, up 3, 1, 2, 3, and over 1. And then when you're graphing inequalities, like when we did it on a number line, if it had an equal sign, it was a solid dot because that number could be the solution. Just like when you're graphing two variable inequalities, if you have an equal sign, so whether it's like this one, greater than or equal or less than or equal, when you connect your dots, it should be a solid line. So I'm going to go ahead and use my ruler now to connect these dots as a solid line. Now every coordinate point that is on this line is a solution to this inequality. But there's also, obviously when you have inequalities, there's infinite solutions. So I'm either going to shade this side of the line or this side. To determine which side you should shade, you should choose a coordinate point. If the coordinate point makes that equation or inequality true, then you would shade that side. So an easy point to plug in is the origin 0, 0. So I'm going to go ahead and do that for this example. I'm going to plug in 0 for y. I'm going to plug in 0 for x, and I'm going to solve this. So this would be 0 is greater than or equal to 3 times 0 is 0 minus 4 is -4. And 0 is definitely greater than -4. So because 0, 0 works, everything on this side would be a solution to this. I would shade everything on this side of the line. Now remember, this goes on forever, so you would shade everything that's on this side of the line, every coordinate point. So for example, -2, 2, which is a coordinate point in the shaded region, when I put that in, it would make that true. My second example is when I have a negative slope. So again, I'm counting by 1, so I'm going to start at +5 for my y-intercept and make a dot. And then my slope is -1, so I'm just going to go down 1 over 1. Shouldn't take too long. And then if you notice this time, there is no equal sign. So anytime you have a less than or a greater than symbol with no equal sign, when you graph it, it has to be a dashed line. In other words, you do not make it solid. So when I do this, I just kind of make little marks in between the dots here, and you can definitely see that it has a dashed look to it. And then as before, I either have to shade this side or this side of the line. So again, because 0, 0 is an option, I'm going to use this to plug it in and see if it works. So when I put in 0 for the y and 0 for the x, well, -0 is just 0 plus 5 is 5. And you can see that 5 is bigger than 0 and 0 is less than or equal to 5. So because 0, 0 works, that means everything on this side would be shaded. So every coordinate point on this side of the line would make a solution to this inequality. My last example for linear is just when y is greater than x. So if I just graph this as y equals x, that means 1, 1, 2, 2, they're all going to be like this. And then when I look at this, there's no equal sign, so it should be a dashed line, not a solid line. And then I have to choose a coordinate point. Now nothing on this line would be a solution because it's dashed, and because 0, 0 is on this line, I can't use that to check. So what I'm going to use is I'm going to go ahead and use 1, 2, 3. I'm going to use 4, 0 as one of my coordinate points to check. So I'm going to put in 4 for x and 0 for y. And 0 is not greater than 4, so that dot doesn't work. or coordinate point. Because that doesn't work, nothing on this side is going to work. So I'm going to choose a coordinate point on this side. On this side, I'm going to go ahead and choose -3, +2, which is right here. So if I put in -3 for x and +2 for y, clearly you can see that 2 is greater than -3, so it does work. So I would shade everything on this side of the line. So the main thing I want to emphasize from this is if you have an equal sign, it's a solid line. If you do not have an equal sign in your inequality, it's a dashed line. Second thing, when you're shading, you just choose a coordinate point. If the coordinate point, when you plug it in, works for your inequality, then you shade that side. If it doesn't, then you should choose the other side. And obviously in a linear equation, one of the two sides work. If neither side works, double check your math. You might have an error.